Good evening, everyone. Kindly let me know if I'm audible or not. Any of the audience, can you please confirm?
Yes, you are audible.
Thank you.
Manas, am I audible? Manas?
Yes, sir. Good evening. You are audible as well as you can not seen now. Yes, sir. You are audible.
Fan off fan. Ghosh? Manas Ghosh.
Yes, sir. Yes, sir.
Yeah, am I audible?
Yes, sir. Absolutely perfect.
Okay, I'll open my video. I okay. Manas,
Yes,
good
sir.
evening.
Yes, sir. Yes, sir.
I'm
Everything
I'm on
okay?
time. Yeah, I'm on time.
Yes, sir. Absolutely.
Okay. So can I share, or we'll just have a rush and then I'll unshare, or you have to give me permission?
Sir, our program is like this. I will just give a little bit of introduction of the program. Then
Yeah.
I will read your then I will read your CV.
Okay.
Then 3 minutes lecture by our Director General,
So
and then it will be up to yours. You can share from then onwards.
no, I just want to make sure that everything
Okay,
goes well.
okay, okay. Yes, yes. You can make a trial run.
Yeah, I'll just like
Uh,
I screen. Is it goes?
sir, not yet. It's not seen.
It's not saying.
No.
Masuk Bay. Dalam na? Tenang lagi. Ada di
Sir, now you try
Oh,
of
one
sharing.
second. How do I get into full screen?
Plus, nothing is coming at this moment.
Okay.
Good evening, Professor sir.
Sir, good evening.
How are you doing, sir?
I'm from a Mac machine. Is that the issue? Shouldn't be, right?
I couldn't follow. You're telling something?
So I'm on a Mac machine.
Not an issue. We are able to hear you properly. You are absolutely audible.
Okay, 1 second, sir. I'll try to.
Sir, I think then you will have an option of share full screen.
Yeah, I'm just trying. Say entire screen. Whiteboard. Computer audio. Am I getting?
Yes, sir.
Are you seeing my screen?
Yes, sir, we can see.
About the presentation?
Now it will come, I think. We can see your screen.
1 second.
I think you have to click on this INSDAG 25 August PowerPoint.
So we can see the PPT
Okay.
where you have made INSDAG 25th August.
Okay.
That file you can see, you have to, I think, click on it to open it. Yeah, you can click that.
Yes, sir.
Is it visible?
Yes, sir. You make it full
Okay.
screen. Yes, it's absolutely perfect, sir.
Okay. So I'll just unshare. Can I unshare?
You can
Sir,
unshare. Yes, you can unshare, and once the initial formalities are over, sir, you can again share it.
Yeah. So
Or you
is it?
can minimize it, sir. Better.
Yeah, minimized.
You better minimize it, sir.
Yeah, I'll minimize and once is it now off the screen?
No, it is very much there in screen, sir.
Still is screen.
It is on the screen, yes.
Okay. Oh, there's only one share option.
Sir, you keep your presentation in this way.
Okay.
We two will be speaking only. We won't be presenting anything.
Okay.
So
So
we'll
let
just
the
take
screen
2-3 minutes. So you can keep
Ah.
this presentation like this, and then you can carry on from here. Otherwise,
Okay.
you do not know, there may be some teething issues.
No, I'm just presenting from Mac, and it's very new. Anyway, sir, go ahead, sir.
So let it be like this.
Can I lecture some moving slides?
No.
Yes, slides are moving, sir.
Okay, fine.
Let the screen be like this.
Yeah. Okay.
So let
if
us
there
wait for
is
5.
Yeah. No problem. No problem.
Let us wait for 5 minutes because the participants are just joining,
Yeah.
and then we will start.
Yeah.
But
Actually, Ghosh, yes, sir.
I have a request, Professor Jayachandran sir.
Sir.
I know Mr. Ghosh must be interacting with you, and he also keeps me posted about what discussions are happening.
Yes.
May I remind you, sir, when I had gone there, we had
Yeah.
discussed about a technical journal.
Yes.
And Mr. Subramaniam also, he also wrote to us once from, I think, America, some other, Mr. Ghosh, he was in States that time, no? So
He actually stays there.
Okay. Yeah. He's in Gothenburg.
Dr. N. Subramaniam.
Yes.
He also wrote to us, why don't you start a journal? In fact, that happened maybe 1 or 2 months after our visit to you.
Okay.
So my request, sir, how we can initiate a good quality
Sir,
journal, sir?
I will definitely, sir.
So
Definitely.
Dr. Abhay Gupta is here. Good afternoon, Dr. Gupta. Sanjay Agrawal.
Good evening, sir.
Sir, good evening. Good evening.
Good evening, sir. Good evening.
And Professor Prem Krishna also is there. Sir,
Oh,
namaskar.
good. Sir, pranam, sir.
Great to see you, sir.
Sir, thank you so much, sir. I mean, luminaries in the panel, I mean, very honored and humbled.
Sir, they are
the luminary is going to lecture.
And Professor Jayachandran,
Sir,
Professor
please.
Prem Krishna and Dr. Gupta, they are also our Executive Council member.
Oh, okay.
So they have been guiding us from time to time. What are we doing?
Yes, my privilege, sir, to interact with such an eminent body. And I'm happy that we are able to contribute to the steel construction in the country to some extent.
Absolutely.
Sir.
And Mr. Ghosh, now it is 6 o'clock. We can, you can start the formalities.
Okay, sir. We will be having the participants will be joining as we see in all the cases. So let's not wait. Let us start the program.
Okay.
So good evening, all the participants. This is INSDAG's 29th year of foundation. So during this foundation, we celebrate it by a popular lecture. So this time, our lecturer, our presenter is Dr. Arul Jayachandran. He is the professor of IIT Madras. So a little bit of CV. Dr. Arul Jayachandran obtained his MS and PhD from IIT Madras for his research on the computation stability of steel structures. He worked in SERC, CSI and SERC Chennai for two decades as a scientist in the structural steel laboratory. Then in 2010, he joined IIT Madras, guided 16 PhD and 5 MS students on steel structures. He was a visiting associate professor at Georgia Tech USA, a visiting senior fellow at the University of Wollongong, Australia, and on a sabbatical at SUNY Buffalo, USA. He is on the editorial board of the International Journal of Advanced Steel Construction. He has published over 100 papers in international and national journals and conferences. In the BIS committee, he is the convener of the revision of IS 800 2007 and IS 11384 limit state design of steel concrete composite structure. He is a member of the design team that won the NHAI Silver Lotus Award for the all steel flyover at Marathondam. He won the ISTRAC Outstanding Designers Award for designing the Madam Jayalalitha Memorial Chennai. He is a university hockey player. He represented the IIT Madras hockey team and won the Most Valuable Players Award. In person, he is a very good person at heart, amicable, cooperative, and a very good human being. So let us start with this program. The topic of his presentation, as we can already see, the future of structural steel construction in India and the emergence of high strength steel. So with this, I would request our Director General, Mr. P.K. Mishra, to share his thoughts. So over to you, sir, Mr. P.K. Mishra.
Good evening, Professor Arul Jayachandran,
Good evening, sir.
And to all the participants. We are privileged that Dr. N. Subramaniam is here, Dr. Prem Krishna, Dr. Abhay Gupta, and many such eminent persons of structural engineering are present. And that gives a lot of confidence to us that all our activities of INSDAG, whatever small activity that we are doing to promote the use of steel, that is being heard, that is being watched by such senior professionals and experts. I am really grateful, Professor Joychandran, that you have agreed to spare your time for this event. And my request to the participants, please make best use of this occasion, because Professor Joychandran is a veteran. He is one of the best names of structural engineering in the country today. A little bit of INSTAG for those who do not know about the institute. The Institute for Steel Development and Growth, this is a not-for-profit organization developed by, promoted by Ministry of Steel, Government of India, along with main steel producers like Tata Steel, JSW, SAIL, AMNS, and RINL. And we have got more than 1,000 members, individual, institutional, and experts. And our purpose is to find ways and means how consumption of steel can be promoted in this country. Because you know our per capita consumption is hardly 100 kg now, whereas the world average is very high. So it is about 223 kg, and China is about 640 kg. So how can we scale up the usage of steel in our construction? That the purpose for which the institute has been set up. We are doing many training programs. You can see the website and get an idea about various training programs that we are doing. In fact, all these training programs, the ideas have come from the users, from the professionals. We are also doing 2 certificate courses. One with ACRC Chennai. Professor Jayachandran, you know ACRC Chennai was your earlier organization. They have been doing a certificate course and it has been very popular. Another certificate course also we are running with IIST Shivpur. And third one we are going to start with NIT Trichy. So I was just before the program, I was making a mention to you. We look forward to your guidance, sir. What kind of initiatives we should be taking so that the gap which exists today in the knowledge of steel application in the professionals and what they are learning from the academic, BTech courses, how we can fill up that gap. That is what we are trying to address, and in our small way. And how we can do that with the help of experts, that is what we are trying to do it. Through training program, certificate courses, and so we are doing a lot of case studies. Recently, we have brought out a publication, Compendium of Landmark Steel Structures. Professor Prem Krishna has seen that. I will be sending a copy to you. Again, that is an idea how steel can be best used in various critical applications. So these are the kind of activities that we are doing. And our intention is that INSTAG should be the first point of knowledge dissemination about steel application in the country. And that is what our humble objective is. We are working in a number of ways. I request the participants to see our website, visit our website, see our activities, give their suggestions, give their ideas, what all we should be doing. Now, with this, I request Professor Jaitendran to take over and deliver his lecture.
So,
Sir,
thank you so.
before sir starts,
Yep.
just a reminder to all the participants, please keep yourself mute. We are actually in the meeting mode in Zoom. We are in the meeting mode of Zoom. So please keep yourself muted and let Dr. Arul Jayachandran deliver his presentation without any hindrance. Thank you. And
Okay.
sir, now
Yeah.
it is
Thank you, Ghosh.
yours.
Mishra ji, thank you very much for inviting me. I first of all submit my pranams and respects to the Professor Prem Krishna and all the word I said, luminaries attending this lecture. I'm really honored. I had met Professor Prem Krishna a couple of times in SARC when he came to visit Dr. Lakshmanan. And space structures and stool, when there's no good a person than Professor Prem
Live ல போட்டு
Krishna.
தர சொன்னீங்களா?
So somebody has to mute the mic, I believe. Okay, so it's a pleasure. 2 hours is a very long time, Mr. Raji, but I'll try to make the lecture as informative as possible. Regarding the one aspect that you touched upon, how the linkage between the undergraduate level steel design to the engineering is a very complex and nice issue which we need to confront. So I will talk at the end of the lecture. I'm going to have some free time, so question time or interaction time. So we can discuss that point. I'll share my experience and we will go on. Okay. Ghosh, all set? Everything is there? Is my slide moving? Is my slide moving? Ghosh?
Yes, sir, it's moving.
It's moving,
Yeah,
sir.
okay. No,
So
sometimes
you can start, sir.
yeah. So sometimes I'm talking to the screen, so I just want to make sure that I'm audible and everybody is. So first of all, I would like to. This lecture is I have made it as something is more of educative to the engineering community, the designers, the engineers, the students, over participating. So I feel even the engineers who work in big companies in our country lack the pan view of the whole industry. They do not know where is the coordinate, what is the aspiration of the country, and what is the work, what are they working for, and what is the big picture is being, being followed. I'm a very fan of Professor Devdas Menon. So he used to deliver us a lot of lectures. So he was telling us an anecdote which he has read somewhere. And the Taj Mahal was being built. People all were cutting stones. So a passerby went and asked one guy, so "What are you doing?" He said, "Look, I'm cutting stone." He said. So he went to another guy and asked, "What are you doing?" Then he replied, "I'm building Taj Mahal." So although he was doing the same work, so he has envisioned what is going to be there. So my point is many of the engineers, that young engineers who work does not know their coordinates. So probably I take this occasion to educate about the activities of being pursued by the government of India, So most of the time we can align our aspirations with the aspirations of the country. And we are all structural engineers, and of course we do all design. So, but steel structures is special, and this is the time, few occasions they will come to learn about the big picture of what's happening in India. Okay, so this is my own personal view. I've been in this passion for over 40 years. Structural steel and stability has been part of my life. And I don't reflect IIT's views necessarily, but some of them are based on my own profession. Secondly, I might use names of organizations purely for putting context to the people. If I say L&T, then people know like how big is the organization. So if something is not made, I mean, I would just want to say that it is purely an omission, unintentional, and ask your pardon. Okay. First, sir, I would like to have not too many topics, but I just want to have a broader I mean a broader picture of what the industry is going to do. First, I thought like I will give understand the world dynamics, right? And what is India's vision? And as whether it is a possible acceleration of steel usage, and of course the point is AI we will discuss at the end, and what happens to the codes that going forward. Okay, so understand the steel dynamics. Is it now we can see Ghosh, Ghosh? Can I go back and have another? Probably the one I'm showing is not the one I'm intended. Can I stop
Yes,
and
sir.
go back? Yeah,
Certainly, sir.
I
Certainly.
will stop share. Right. Let me go, please.
So participants, let's
Yeah,
wait for a second.
I'm just saying.
Recording in progress.
Yes, sir. It's visible now.
Yeah, is it fine?
Yes, sir.
Okay, let me
So
check.
you can, sir. Sir, you can continue.
Yeah, so very sorry about these things. I had too many versions of the presentations. Okay, so first is understanding the steel use in infrastructure. Oh, somebody has to mute. somebody has to mute. Okay. And secondly, accelerating the use of steel and how the high strengths and the new codes of practices come, and finally, the summary. Okay. Right. Now, what is the install capacity of India? To take things, so we always want to grow. So right now, we are about 200 million tons per annum the capacity. And when the demand comes from housing or infrastructure, the PEBs and the likes, the demand is going into, I mean, the production is going to be high. And we also see the new ones are being planned, the JSW POSCO joint venture. But one thing is there. So we always go by the BF rope. So the blast furnace, basic oxygen combat process. Now, when I visited Scandinavia, then I don't want to name the country, but they are producing something, I mean, the green steel, which India also, we are doing many initiatives towards what is called green steel. But what is my worry is we have developed to a great extent in the BF and BOF process, and we are almost self-sufficient in production. So I'm really afraid that any of these climatic issues, based on that, any non-trade conditions might come into our steel industry. I know the country as a whole we will confront that, but I'm just a little worried that we have to gear ourselves up in an eventuality of things with the climate based, either in trading or use of steel. India must be ready by another 5 to 6 years. That's my personal opinion, because that people are going to comment about the BF and BO process, and we should also we have enough potential and this thing, so we should have to get into that. That's the point I showed, that install capacities, and probably the challenge is from the sustainability aspect. And we do our own country, we are really mindful of sustainability and the climate change. But some of in the if you see the world trade dynamics, we should not get inadvertently into a hitch for the growth of steel. Okay, this is my opinion. And let's say the understanding the impact of steel in the use of infrastructure. Okay, this is a chart of the per capita use of this. Of course, Mishra ji, Director General INSDAG, presented a little bit of that, but although his introduction was small, for the crowd, for the audience, I would like to make it a little more knowledgeable. What is INSTAG and where is the coordinate? Why are we have an obligation to be with INSTAG towards our country? Those are things I want to say. Look at here. This is a graph of per capita use of steel is that. Okay, how does it matter? Because usually the usually you can see it is a proxy to the state of an infrastructure of the development of a country. So people say how much is the per capita use of steel indirectly conveys what is the infrastructure growth, what are the basic infrastructure constraints are reflected. Let's say I have an example. We have United Kingdom at about 120, 118, but their population is very late, probably one of our states. We have Germany around 300 kg per capita. United States 261, but they also have a large denominator. But take the case of Japan. They are around 450 kg per capita. Of course, their population is less, but still 450 kg is too high. Given the fact, I don't think there are any coal or iron ore in Japan. I'm sorry about my not a good knowledge in geography. I still feel that there is nothing there in Japan, whether it's coal or I mean, but they have the innovation to try. So they use about 450, and the world average is about 200. So we are halfway mark. But I would not take it as no, we are not at par with the world average, but I say we have a lot of potential to grow. So in the in the steel structures, when we say thin plates, we take more post buckling strength. That means we say it can take twice of this strength. Is it? So I say a very similar case. And of course, we are pitching around 100 kg right now, but we are planning to increase it. We have a formal policy. But I would like to tell the listeners, especially the young people, so this is a metrics that the whole world will measure our development. So, I mean, if it's possible, you can dedicate yours to do a very good design of steel structures, possibly into assets which are very good to our nature. Okay, having done a little idea about what is per capita consumption of steel, um, there is I mean, common acceptance. Every country who want to sell more steel has a specialized networking organizations. I wouldn't call that, an institute. It's not an academia. It's not a group of scientists, but it is a passionate kind of people who really are interested in expanding the steel construction and of course, the aspiration of the country. If you take Europe, the ECC is very, very strong, right? There are some steel producers have their own institutes, but still, the European Convention for Professional Steelwork, a lot of conferences, material, and the codes of practice support material, everything. Of course, everybody knows about SCI. SCI in 1970s, UK went through a very similar crisis that India went through in the late 90s. And so they systematically went and found out the SCI, which today is have grown big. And of course, in the past, we have worked with SCI, and I'm sure we'll be working now also. Of course, BCSA has a little historical background. So the American Institute of Steel Construction, I tell you, amazing people. Primarily it is run by the fabricators and the steel producers. They do very systematic work, right? So we have Canadian Institute, we have Australians, we have Chinese, and we are about the Arab and the Middle East Union. So there is the specialist organization who's integrate. So in India, we are fortunate from the mid 90s that we have INSTAG, Institute for Steel Development and Growth, under the Ministry of Steel and Government of India. Primarily, this is an organization which has got the the wherewithal and the capacity to reach out to the masses from different stakeholders, may it be designers, the end users, the fabricators, all can have something from the INSDAG. So I would say the INSDAG has been a great organization, and it is my duty to mention that. And also, I would like to show you the graph. Okay, this is per capita consumption of steel. When we started in 1991, something like that, it is 3 or 4 kgs. So this data shows that we are 10 kg per capita per person. But we were like 3. Now, at about 91, 92, India, we moved from an administered pricing regime to an open market pricing. That means earlier to that, the price of steel was um, was a regimented one. So the government, there are few organizations who will make the calculation how much steel is produced, how much is the demand. So they fix the prices. There is no proper, I mean, the real market push-pull forces which come into it. So later, INSDAG was formed in 1996, if I'm right, and
Yeah,
it is
Harshal.
the yeah, it is there for us to see that there is a great growth after the inception of INSDAG, and we have now reached about 100 kg per capita. I'm not attaching the entirety of this effort of the steep rise in that, not only to INSDAG, but I would like to make on record INSTAG was the integral part of government's every step towards that. So first of all, um, our country, we have a national steel policy released in 2017. We are aiming to go around 160 per capita by 2030. So it's not too far off. So I feel INSDAG's role in training and codes of practice and is very pivotal. Always we have a very ambitious goal, our government of India, because it believes in us. We have tremendous potential. So it is not the government says some numbers, but say we have real good potential, and then it expects all of us to live up to the expectation. Okay, so in that nearly been 30 years, it has turned thousands of engineers, and I personally only presented data that inception of INSDAG and the steep growth of stills has become very synonymous. Okay, so a little bit fact about the people who are young people have gone over INSDAG, and it was established in 96 when there was a very low uptake of steel, and we went into the open market in steel policy, and the need for a specialized organization was felt, and INSDAG was formed. I'm very happy to say I'm one of the founder members of INSDAG. And then first DG was Madirata, and at that time, Professor Narayanan, SCI UK was here, and Mr. Narayanan from the Steel Ministry was guiding the INSDAG through Madirata, contacted Professor Narayanan from UK, and Narayanan put together Kalyan Raman, myself, Professor Shanta Kumar, Dr. Sita Raman, Professor Satish, and Dr. Sendil, all of that he made a team, and then we were doing the initial work of that, right? So the early 90 outreach by the INSDAG for awareness of architects, popularizing steel construction manuals, all these things, we were very happy part of it. I have seen many young engineers at that time of my age, and we used to run around. Once we were going for a lecture to Coimbatore, near a place like Coimbatore. So I was in the train, and Manoj Ghosh came and searched my compartment, and he made sure whether I was available. So we had a fun of traveling and teaching and make awareness. So in the 2000s, of course, it has graduated because composite construction has come in a big lab. There was awareness about IITs and CSR labs, and the INSDAC started coordinating with them. And after that, in the 2000, after that, they started, having their own design books. See, first of all, we should understand. See, they have all wherewithal to collect all the technical information and disseminate all to us, right? So per se, we say there is some technical excellence available. Is there? They are people who can get your expectation of technical excellence from somewhere, right? In the 2000s, they have done lots of seminars and work with prefabricated and modular construction, and they're also part of the discussions on smart cities, affordable housing. I will come to the point on this thing, and every year they conduct the competition for the architects and engineers, which is very popular. My students have twice won. I think one of my student won first prize, was a single guy. Another three students got the third prize. It is a very popular even for the students and these things. Kudos to INSDAG. They still maintain, because this is a difficult logistic exercise. They have been doing this. Okay, so there is my own introspection about INSDAG. I would like to say is, it is an organization started as promotion for steel construction. So initially, it fell into some crisis of identity because some of the patrons looking for their own books for is there any increase in sale? It was too early for INSDAG to have taken that burden. So I was also part of it, which says, oh, we will one day we'll do it. So initially, it was the expectation side. Secondly, the INSDAG was seen as a solution provider. Right. So even in IIT, if you come, we don't have solution to all the problem of stakeholders. Right. Neither INSDAG. But they, as I told you, they are capable of getting that information for you. So I was sad once even INSDAG was pushed to take up even design checking. Correct, an organization was pushed to design checking, which was too much the things for an exec. So I would say, as an outsider, I mean, those were the things we were really with InStack helping and things like that. Now everything is fine. We are doing most beautifully. It is my opinion, and now it's I would say is a vibrant networking organization with an motto of steel education, publication, codes of practice, and promotion. So, in tandem with the best institute of India, they're a big mover of the steel construction in India. So now they have surpassed 30 years, despite I would say facing difficulties. I mean difficulties. Now they are a private organization. So, Misra ji, I give my claps. Congratulations for your team. I could put together this picture. I see my old friends, Manas, A.K. Samantha, Arjit Guha, and of course, I don't find the other names there. So, wonderful team doing really good. Your visions are um, your vision is to make our country great, and it's definitely my big congratulations to INSDAG, and I'm honored to deliver this talk. And thank you, Ms. Raji. Okay,
Thank you, sir. Thank you, sir.
If the participants have can fly claps in your screen, please go ahead and give INSDAG your claps and bouquets. Okay, right. Okay, thank you. So, having given a little bit of a background to this, let me start doing this. What is the aspiration of a country, and what's INSDAG is doing, and what's your coordinate? So, the question I put is, where do we go from here? Right? Our whole intensive is called steel intensive construction. I start with no other than the temple or the monument of steel bridges, our Howrah Bridge. I had the big fortune of walking on the entire length, and we have a small cabin monorail under the deck, so we can go into it. So it was a very nice exercise. I went down. So the question still links: where do we go from here? Because what is in store for us? I just casually, I mean, when I was doing the presentation, I just had one slide which I gave around 2005. So this was my slide on where does the Indian steel go? Right. So at that time, I remember it is 18% from the construction, the white goods, the automobiles, that's about 40, rebar is 20, about non-structural 22%. So that was an indicative data at that time, and that was the thing we were to start. Okay. But today, I see the steel consumption that we are looking at to 2030 is a whopping 62% from the construction and the infrastructure. Right? You can say the 10% automotive is there because the pie has become very big. Right? The pie has very big. Of course, we should be doing more on defense, but this is our future 2030. Definitely, we can always work and coordinate more on the violent, the defense side. So this is a big, big leap from 18% to about 62%, about 4 times on that. So what do we have to do? Is that what my question? So, in my own opinion, I'm not saying that I've solved the problem of the world, but in my opinion, I can give my professional opinion of what can be done to bridge the government of India's big aspiration and a leap in the usage of steel. Okay, so this is black and white, right? The grand challenge in steel construction ahead of us, the national steel policy is set. As you can see here, it um, it aims to go around 160 kg per capita. So that's from 100, another 50% increase. Now, how is the roadmap? You might have read the Gati Shakti, which has got 7 engines, which drives the growth. And if you go and see and knock them down into the what is for the steel sector, so it is very nicely laid out. Right. If at all we want to grow to around 160 per kg per head, then we need to, the first priority is construction and infrastructure and engineering and fabrication, automotive, the other tab, and the packaging. Right. So there are minors, but the major chunk come from the construction and infrastructure. Now you can see here, it starts with steel, the oil, the highways, bridges, the airports, all of them have to contribute to that because this has been mentioned not like say enumeration, but it is everything has been arranged in a thoughtful way. That's what I like about these aspirations of the national steel policy, and then it gives us more authenticity and more interest to pursue that, right? Now we can see here, I'm going to really look at what happens if a highway, what happens if bridges can be expanded, can airports bring in more steel, how about ports, urban infrastructure, prefabricated building, which I'm really excited about, and power projects, so oil and gas, all of them, the construction infrastructure have to grow. So we have to grow another 50% by the next 5 years. That means we have a roadmap. Now we are thinking what can make the consumption of steel or what can make the target achievable. So this is what my talk is going to be. And I'm going to share my own experience of how these can be achieved. I would do some predictive um, presentation, and also I will give my opinion in which I was a part of the infrastructure development. So let me start with that, with a big challenge ahead of us. Let us go see one by one how we can do. My first question is, can open web steel girders or of course plate girders increase steel consumption? First question, because the die is cast. I know where to go, but I have to find how to go, right? Or, I mean, what else I need to go? Now, if you take open web steel girders and, of course, plate girders, it's a primary use of railways. They were the major use of steel, major consumers of steel for a long time. In the British time, even after that, even after independence, and we set up several, steel mills by the governmental funding. After there has been a big use of steel in the railways. Now, my question is the same thing can boost our consumption? But I will say the doubling of tracks, which is announced in every budget, and the new alignments, if been adjusted and the funds are allocated, only those increase can bring in the consumption of steel. So probably the most of the rolling or the track stock is in the stage of maintenance, but the new things come only if there is a new alignments and doubling it comes. So, but one hard truth we have to accept, right? So, Priestess concrete have been is definitely used as an alternative. Many instances. It's not one or two, many instances. So, um, in such a case, even for the only the ROB portion, the steel is considered most of the time. Either it is a plate girder or it is a bowstring bridge. These two are the options as being used. But of course, we are a country with abundant cement. It's not about steel versus concrete. We have to do everything in spite of the concrete has been a um, uh, big factor for our growth of our economy. So the abundant availability of concrete, equipment, labor has tilted the scale towards piece sector. I said that is fine. That has to grow. No question about that. But then, in spite of that, how the new avenues can be opened is what I just want to discuss. Okay. So first of all, another thing is the volatility of the steel prices. People always say the volatility, but the government, if we are doing a government project, it comes with the support that you do a base pricing and then whether up will cover. So a little bit of a smoothing. So there is not all that very negative with the steel being used. But I'm not very impressive that the open web girder systems which are used in railways are going to bring us more consumption. Okay. Secondly, my question is, can industrial structures can increase consumption? Okay, industrial structures are basically synonymous with steel only. Right. Okay. Concrete being part of it, mainly it is always at every instant of time. If you see that, they have some constant share of steel being used in industrial structures. Right. So unless we get new industrial conglomerates with heavy usage of steel, we are only seeing a few at this moment of time. Um, so the point is the industrial structures, of course, they do use tool, but will they drive the demand? I would say no, or the possibility is very low. So industrial structures only be there when there is a capex and the companies want to invest, and industrial is not a big driver of that. Okay, so the third question is, how about the PEB industries? I am really excited about these PEB industries. They're doing really well. I have been part of this PEB industry nearly 25 years. In the year 2000, we had a conference in Chennai, and at that the time, the first time I saw Kirby people and the Australian Tata Blue Squadron. It was a different name than they charged the name into Blue Scope. And they were there and they made a presentations about the pre-engineered building. I still remember who are all because it's about 100 people. From there, after Kirby landed, we have widened, and PEB industry has been a big promise for the steel growth. So if you take the current in the market size, it's about 1.84 billion US dollars. So at 230, I mean, in the year 230, if you want to project, it's going to double. It is going to double. So definitely, because the reason is they are not just enclosures, right? So we can see the seventh engine, our Gati Shakti, which is our government of India's long-term plan infrastructure powering engine. You see, the seventh engine is the logistic infrastructure. So the drivers are warehousing. Now I see is a very interesting concept in warehousing, right? So it's not that everyone has to have your own storage. There are common storage spaces which are given in rent. So the aggregator of the services will provide you with the logistics of putting in, getting you out, and you can share the space. So, which is a very exciting idea for me, because a person which can produce need not have to have a space for his own. So this is a new one. And of course, logistic parks are being planned. Of course, data centers is a big growth, and EV and electronic plants, and even in cold chain, right? Although we are not very, exporting, they say, but cold chain is now becoming this thing. So most of this need enclosures. So I feel the PEB industry correctly fit into this market. And now what happens if you take the PEB, I would also include the rack industries together. Today, because all these enclosures, the racks are used, Now we have rack-supported buildings have come. That means the racks basically will take the gravity load, and the lateral load is taken by a system in which the load is not transferred to the racks, but a system of lateral force transfer. So the racks as well as the PEBs go together. And now the PEB majors are there. I don't want to name them, but they dominate the install capacity, about 200,000 metric ton each. But there are several other fragmented market with smaller vendors. So that is what I don't know. They don't come into the normal calculation, but I can see a lot of PEB vendors, small time PEB vendors doing good business in the um, I will say the Mofussil areas. One of my personal experience was in Madurai. So when I went, the first time I saw a pre-engineered building that was used for some manure or something like that, but it was near to the bus stand. There is a bus stand called Matutavani bus stand. So it is very near to that. It's a open field, though easily people can see. So after from 2, 3 years near the Dindikal bed, I saw a lot of these PB buildings have come. And one near to my native has come. So I went in, I asked them, they said, sir, the one which is near to the bus stand, it is very good. So I feel, and after that, people started seeing the quickness, and it gives a lot of space for them to use. So there are a lot of fragmented market, and definitely the industrial and infra capex for the companies will definitely fuel the demand. Of course, many of the work is being done by the PEB majors, but the second, I would say the non-primary or the minor people are going to invest in that. So I'm really, very encouraged that the PAB industries are going to give us a good push, and which aligns with the seventh engine of our Gati Shakti. So kudos to PAB industries. I've been with thick and thin of them for a long time. Right. Now, another concept which I feel, which is also comes in the infrastructure, is in bridges. Right. Of course, we have reinforced concrete bridges for a short spans. We have PSC, which can be done with zinc. So, steel as a part of complete bridge is the one. The chance came to us very accidentally, and we just took it and then tried some improvement and implementation and learned quite a lot. I'm going to share that idea with you. So this is called all steel bridges and flyovers. Okay, the first one that we saw was the AGC flyover in Kolkata. So I went with my own students team, and then we went into the Sauda organization, something which had all the documents. So we had a look, and then we replicated or learned from that and made about 4 kilometers of uh, all steel flyover in Marthandam, the southern part of Tamil Nadu. And right now, one is going to get completed in about 2 weeks, and it'll be open for traffic in T Nagar. And as you know, the T Nagar is the business district of Chennai, lots of commercial activities, and in that we were able to do this concept of all flyover very efficiently without much of the business disturbance. Okay, so they are basically steel spans. All are fabricated and launched at night, usually causing very minimal traffic, or we do blocking of the road for a minimal distance so that all other areas are undisturbed. So we use the closed or the blocked space. It keep changing from place to place. So making the entire stretch not blocked, but only a few part of it is blocked. Okay, so the roughly it's about 110 crores from, say, we are just recently completed, so that's about 110 crores. So I'm just saying that I'm trying to be conservative, or if I take a base or ambitious, by 2030 we can have, if it's ambitious, about 500 kilometers of the flyovers in very busy cities. Okay, So it is well best suited for mid-sized cities needing quick build flyovers. You will come, you will see in a while from now. So when we took up the challenge of providing a flyover in a very narrow, people have been very negative about it. But once we soiled the hands and doing each and everything, we really understood that is a good concept which may be adopted. So let me go into that concept thing. So this is the first the photograph we took from think is Hooghly Bridge River Corporation, correct, Mishra ji? Is this organ? I took this data. Is that right?
Yes, sir. Yes, sir.
Yeah,
The
yeah.
name is okay. Hooghly
Okay,
River
fine.
Bridge Corporation.
Okay, River Bridge Corporation. So we went and fished through all the old documents, and they're very fantastic. And this is basically a Japanese design. So you can see here, I will explain to you. This is the base of a pier, and the pier cap is in steel. And I will explain to you that. So this is the AJZ flyover. Now you can see what I was amazed is at that time, they had a plate girder. Of course, this is a steel composite bridge. And for the obligatory span, they used a box girder composite. Mishra ji, am I right? It's still, because this is an old photo and I took my own photo. It's still, the place is buzzing with activity.
Yes, yes, sir. It's
Manas?
completed now. It's
Okay.
completed now.
No, it
We
is
are
completed
traveling
long
there.
time back.
Long time back. Yes, sir. You
Yeah,
are
it's
okay.
long time back. But no,
Right,
we were there. This is a construction photo. So
right,
it
sir.
is long time. So this is our inspiration. So um after that, no, we learned basically this flyover was designed by Yachio engineering consultant, and L&T was the EPC, and the superstructure and the box girder or prefab guard segment. Okay, let me explain to you how this concept is viable and how it can be used. So let me take the pen. Now we can see here, this is the space where the pile cap comes. So inside the pile cap, we are embedding what is called an anchor frame. So the concept of anchor frame is very simple and very, very ingenious also. You can see here, there are rods and there is a nut here. The rods goes from here to end in the down, right? So at the bottom, we have another nut. Or if I want to draw here, there is a nut here. So there is a nut here, there is a nut at the bottom, and it extends up to the top. Okay, now what happens is that when we fill it with concrete, when there is a downward compressive load, right? When the downward compressive load is there, the top nuts are going to transfer the loads, because it is being the load on the compression, the top of the nuts are going to transfer, and when the load reverses, the bottom is going to transfer the load onto it, and of course the load dispersion will go this way, and if there is an uplift, the load goes this way. So this is embedded into the pile cap, and you can see here there is a small frame comes in the pier cap. So these are the rods or the anchor rods which are projecting out. The diameter is about 80 mm. Sometimes we have used 90 also. So a similar nut is also there. So this pier actually is embedded into the advantage is that we can easily install it in the night. If you have one pier, we used to do almost one or two piers a day. Okay, the next is, this is an example you can see here. This is the pier, the pier, and the pier is attached to the anchor frame. Now we can see here, once the pier is made, which is of steel, the entire area is for, say, at least two-wheeler commutation, smaller vehicles can go. Of course, lorry and buses can go, but minimal disruption to the economic activity. So first we block the road for the piling. Once the piling is done, the anchor frame is cast. Once the anchor frame is cast, and when it is queued, we just give the pier, and that's it. We remove that place for traffic. Now the pier cap will come in here. The pier cap will come in. We have a handhole in the bottom pier cap, so it is set, and the bolts are from inserted, and they are torqued to the right value. So it is a very simple operation, and with low weight cranes, they can be done. In a day, you can about do 1, 2. Only thing is the initial bolting is done, and then we go torquing. So what we have done is in T Nagar, it is just going to be over. It starts from CIT Nagar and it will end at Northwest Mount Road, where Dr. N. Subramaniam's house is there. Sir, we have a bridge from CIT Nagar to your house, sir. So Marthandam, and of course, Kerala had 10 flyovers given by the RBDCK, basically funded by the KIFBI. So all of them are there. Last 4 is being released. So the concept is well tested. We have learned it, and that is how we say like whether this can give us the thing. Right now, after the this thing is there only plate girders come arrive. So it is not basically a stone. Right. So most of them is the stick constructions. The girders come, arrive, and go on top. Come, arrive, and go on top. So it is very easy to, they construct by the stick method. For example, in case of India, suppose if we think that if this is an option, then India, we have about, I'll take the laser point. India, we have about 4,000 cities. And of course, by the global, the urban is going to be about 607 million. So, 2/3 of cities will definitely need an upgraded infrastructure, right? Right now, we can see a lot of second and third tier cities are there. Now, if we say, let's say we target about 75 to 100 mid-sized cities, right? Tier 2, let's say tier 2, 3 million plus cities, and which may need but 2 to 5 kilometers, and across 2, 3 bottlenecks, right? So we are targeting only a few of them. Then if we take the uh, estimate of 110 crores per kilometer, which we took Chennai as the base. So actually different costs can vary. Now, if the adoption of say 75 cities, we have a capex of about 16,500 crores. An ambitious estimate is about 55,000 crores. It is my own estimate. Of course, the variability of the adoption and the acceptance of the municipal community, all are there. But since it has been tested about a few times, I'm just had a calculations whether it is possible to that. Of course, it works as possible. See, it's not the flyover cost alone. But you see how much increase in the economic activity or how much is the people benefit is there. For example, in the case of Marthandam, there used to be a traffic jam about 2 hours every day and every night. And the people going from Marthandam to Trivandrum in an ambulance, they felt always the difficulty. After the flyover has come, it is hardly 20 minutes to cross the entire thing. So it is many people populated. So I would say if you want to give a small expansion to commercial activity by an access, the business development around that is more. So that's what is my hypothesis. But of course, there are some caveats. I too agree.
Sir,
Yes, sir.
just wanted to know what is the steel consumption per kilometer?
But, sir, about 1,000 tons per ton. So can we
Thank
have
you.
questions at the end? Hello? Sir, whose question was that? Hello?
Participants, we have a
Yeah, let
question
us
and
wait.
answer
Sir,
timing. So let us just
yeah, we'll
concentrate
say,
on
I
at the end
plan
of
to
the
give about
program.
half an hour, sir. Sir, don't worry. Sir, I'll finish it in time. I'm going to give about half an hour. We'll discuss all that practical things because finally it's all about costing, design technologies, I can say. So Of course, see, the most of the time uh, see, you have to have clear corridors for that, right? So the ROW, if the people, the municipal administration is excellent. It is excellent. However, if any land acquisition is there, so that particular stretch alone will take time. But if the ROW is there, it's a fantastic concept. If the ROW is the municipality, it is very simple, right? Only thing is life cycle. Everybody always worried about erosion, right? Now, if you go and see the way we have detail in all these structures is, I can say, the flyover that we built, uh, the post-construction liability was 5 years, right? So the contractor paid zero paisa. There was absolutely nothing is needed till the 5 years, and then it is transferred to the government. Right. So I will say the way we detail, the way we reassure the people that the durability is not a problem. In fact, we just specify the coatings. We did a 3 coating system in which the primary zinc rich, then micaceous oxide, and then another top coat. So if you want to do a repainting, only the top coat is removed. The mid and the base coat will always be remain. Even that it's about 10 years from now, we haven't painted it. It is looking good. So, but there are RDSO and IRC gives us a lot of guidelines. So we have to give that, right? So the cost can swing between, let's say, 110, and depending upon the utility shifting, then other things, the cost may slightly go on more. So it is um, about 900 tons is per kilometer is the kind of minimum that we can use. So also the urban mobility is just 8 tons. So this is one such examples which I thought that can fuel. Of course, there are ifs and buts are there. So this is the flyover. Right, you can see here it was it was a very, very narrow road. You can see here from the deck, people can go into that balcony. And once the piers are in place, that was 5th Jan, and it was completed in 19 December, all open to traffic. So this is one of the fastest thing. The entire 2 stretch were given 2 packages. So both were completed in about 18 months. So there was a central minister who wanted to do this. It was there. So it's only an example. See, of course, there are people who have a lot of questions, a lot of alternatives. So I'm only saying that something we just tested, we can see whether it is that. Right. Um, this is what I said. The flyover programs is look at here. If I take 150, then if it is a low steel usage, right, mid and high, you can see here how much is the tonnage. So it's about 1,200, right? So max is 1,500. So this is all our theoretical value. For example, if we are going for a 2 lane, this is what we have the cost for. The 110 kg per kilometer is, sorry, 110 crores per kilometer is for a 2 lane, right? If you want to go 4 lane, then the cost may different. So it will become more steel intensive. However, if it is going to be an airport access or the return on investment on the tangible parameters is very high. So this is a study that we have done. Of course, this is in tune with our government's Gati Shakti, absolutely in tune with how we can give urban mobility, right, and decongesting our traffic with more flows. So these are one of the pulse of the Gati Shakti. So this is only a proposition. This is only a hypothesis, and we can try to achieve. Okay, so I think I've dwelled on this topic very much, but I'm very sad to see this is the all steel elevated corridor in Sri Lanka, right? So it was an orthotropic deck. Probably it's a Japanese design. I don't know, but it was very beautifully built. Very beautifully built. All these you can see here. All the portal piers are in steel. Very elegant. It takes very less space. You can see is there a lot of space for the water drainage, and then we have a one clutter cover, and all you can see the individual piers also. Correct. So very nicely done. Of course, it's a green field where there is no big disturbance. They were able to go for portal pier, but definitely it's a good concept. So I'm only encouraged to think. So innovation is what is this will make us. Anyway, this is my own personal thing. Is it is possible, and we are capable. We have stalwarts here. Our government is very supportive, and we have to do it. Okay. Fine, sir. So next I go. Okay, in the bridges side, if you want to use more steel, I thought like okay, there is to be not we have to take we can take away concrete or pre-stress, we had to have new avenues. So that's what I said. So what about airports? See, airports are real good in terms of intercity transport or exports and things like that. However, we are also at 2000, 30, we say how this can be there. Can be a low use of steel, base or high use of steel. So what we have done is we are taking about the first 8 is a new big airports. So we say in the low, at least minimum 8 big airports. The base is about 10 and high is about 12. So these are new airports. The second number is the mid-size airports, like the next tier airports, about 27, 40, and 48. This is purely on a statistical scaling only. And then these are the expansions. The last one is expansion. Right. So either with another cargo terminal or another passenger PTBs, things like that we have worked out. So uh, we are on the we are on the opinion that a mild increase can come, but however this increase will result in higher and our exports and intercity economic activity will. The last point will, not the last point, the next point which I'll take care is the housing for India, which I've been very fond of, and we have been, I think. So today, we have about 10 million units we are short. And by 2030, we have to be short about 30 million cumulative homes is needed. And what is surprising to me is a whopping $67 trillion, trillion rupees economy. So it is a very, very, a good scheme. But let us see, what is that prevents us from going in a big way into the an affordable or housing? But the government is doing good. The under the PMY scheme, the government has sanctioned 120 lakhs, and they have completed around 94 as per the Press Information Bureau. And there are 1 crore urban families also targeted over the net. That is by 2030. So this shows the scale of things is high, but still there is a backlog persists. So what is in store for sale, right? So I would say, I'll share my experience. Of course, these figures are to say that steel buildings, Kalpam steel building will be for upper class also, with the experience I've seen in Australia. The coal form steel, the LGSF system, is for the uppermost strata. People want palaces built in the things because they are near the mines and things like that. So there is a beautiful technology which provides coal form steel for the ultra high things. But however, we are talking about um, the coal form steel or light gauge steel frame systems. We did projects at Guwahati. Chhattisgarh was a great success. It was 48 different tenements for the laborers. So that was the first time it was a very experimental basis. So in that cold form steel house, there was Indian toilets were inserted. It was an amazing effort by the Jindal, and it was really done. And of course, for Kerala also, that 418 BOP, below the poverty line dwellings, were also there. But let me share the honest truth. Like whatever the engineers always thought on, not on the livability. A house that is completed and given to somebody, because people have to live. People has to live. So probably the ones that were presented um, could not thought of it's a place for living and where will they keep the things or cook. It's not a simple enclosure that we get in the case of data centers or PEBs. We give an enclosure and say you spill it with whatever you want. So many of them were bare shells with insufficient thermal and acoustic, and occupants per them is hot and noisy. Of course, there is a saying. I myself is an engineer, and there is a general feeling that engineers, I mean, love only objects, or engineers deal with objects. They also treat people as objects. So they say there is no societal mellowed. I mean, societal mellowness is not with the engineers. Of course, I read it somewhere. So engineers deal with objects. So University of Melbourne, University of Sydney have started a painting course for civil engineers. They say like you come and express yourself. You draw an urban landscape and then you express that your structures and people are living. So it is purely sketching. So they say the human nature of the students must be brought out in this. I mean, of course, this is an anecdote I'm just sharing. So probably the idea was good, but the cost was the major and the livability was lost. So I have one success project in Guwahati. It is inside IIT. So I was there in the part from the beginning to the end. Once all it is over and after 6 months, I went and took an interview of the residents over there. So I asked them, I said, do you mean, are you living in a concrete building? I said, yeah, we are living in a concrete building. He said, do you have any problem? I said, we don't have any problem. But the servant maid and those things, they said, the kitchens are wet, a little bit wet. So wherever there is a water, they had a complaint. Otherwise, there was no problem. So it's done in a good way. All the ingredients of a good living were there. Right. Now, the government of India has taken note of this, and then it made guidances to, provide the livability. Of course, there is always a push-pull between the cost and livability. But people think, I mean, I will come to the point now. So um, I say pitch the product and not the material. Of course, we are going to, deliver on steel. But in hundreds of cases, I felt that the comfort was not the prime, is only the materials, right? So that's why I put the phrase as pitch the product and not the material. Right. So it is, we have to do something. So we say some of the things that we say is, I mean, the wall studs, the walls, thermal breakages. Of course, it can, this concept can, really customize people's these things. Really, with people with different, demands can have their own systems, right? Then we say about rooms, and even we thought about how should be the spacing so that the fans can be attached on the metals, because we don't give anything in the normal cold form steel beam. There is nothing that weights the loads can be hung. Right. Then acoustics, about a reasonable level of acoustic has to be there. And of course, corrosion protection. Of course, the cold form steel products already, they come with an impregnation of galvalume or zinc aluminum, about 275 GSM. But still, it is our duty to assure the customer that it is corrosion free. So we have to make sure that some kind of a coating or in the wet areas. So we should talk about some 90-day delivery with standardized MEP pack. This is what actually really impressed me. Is after having looked at what's happened in Guwahati, that wet places where this thing. So I found a gentleman near Krishnagiri, and he had an idea of everything is assembled toilet. So if you go, everything is there. You see it, and everything is made. Power in, water in, and sewage out. Right. So it is actually you have a building, and it is actually lowered into the building, and it is tightened. Now that particular utility is amazing because you are going to in India, our toilet usages are water spilling. So if we can do that area, it was very. I mean, he did a good job, but I don't know. We could not invite it. So I feel the standardized MEP packs and people can be asked to take our Prime Minister's Awas Yojana incentives, subsidies, and sometimes the green home finance. That's something. See, there has to be some appreciation for them. And primarily, I would say the steel housing in by 2030, 31 million. Right. Now, a typical size, let's say 35 square meter, simple thing is. So the frame intensity is about 20 kgs per meter square. And we have, we are using 20 kg, so we say zero point 0.7 tons per home, which is very low. I do agree that, but the reason is whenever we ask a structural engineer to design a housing house, he weighs only the amount of steel that is computed. So his BOQ is only kg of steel. In fact, if you take an individual house or this thing, I mean, let's say a resort, if you're building a cold form steel house, the frame cost is hardly 30%, right? Because the steel frame cost. So you have your the enclosure material, your flooring material. What is the cost of the comfort? So you can see that the share of the frame cost is not that high compared to that. So the remaining aspect only comes on a livability. So what I thought, like, when we present to the customer, it has to be an integrative approach. So steel or people will think they can only sell you only their steel, right? So I just made a small calculation. Let's say the concept is ordered by 5% of the people, right? Or 10% or 20% of the people. So you get about let's say 1 ton to 31 point million homes it into adoption share. So this adoption share, I'm telling you, it is going to definitely increase because I have seen in housing the herd mentality. If somebody has got a very good product, everybody wants to have it. Right. So I feel the adoption, this is a very low level of thinking. Of course, it needs a lot of concerted effort. So I shared it about 6 years back for the people who are designing structural engineers. I say customer is the king, however poor one can be. Because he decides whether you give him a house and say, go live. They just live under the tree and not in your house. So many people think there was a design I saw for a rural home, and the plan had the living room, a bedroom, and this thing. So it broke my heart because the engineer has not understood what is the intent of a person who lives in a village. For him, is all space is there, living and bed, everything is the same. So I would like to give more carpet area to him and a place at the top, putting, let's say, a triangular truss roof, which is difficult in cold form steel. So he will put many things on the triangular part. So this is, I thought, like livability. Sometimes, if I say I have this system, it's all thought, and IIT people have vetted it, you take it or leave it. It's done big damage to the construction. So because we say we are at the mercy of the customer. And the dwelling planning is done by engineers with normal notion like the things. But I feel the women must be involved. They will decide what the unit has to be. If you're going to have a cluster of units, and they'll decide whether they want to have a toilet outside, they want to have a cooking outside. That kind of a planning is make them love and live there, rather than we decide what is will work for them. And also, India is a vast country, different cultures, different language, different geographical this thing. So one solution cannot be there. So it has to be of course, we have organizations like BMTPC working on that, but this is my experience I'm sharing. And one possible thing is a factory mode approach may take the direct or indirect labor. But in fact, the truth, the unskilled labor will be still required for all these services. So it is not a mechanical oriented. In the Chhattisgarh project, there were a lot of tribal women who came and worked in the coal form steel project. So, and also there was a plumber in Guwahati who was a normal plumber. He learned the art of providing MEP in no time. So it is not the dearth of talent or these things. So probably the engineering community do not translate us into things which are you know um, I would say the wall livability in this. Sir, look at here. This is you may not see the figure, but this is Japanese sculpture. This is a steel building, an all steel building. You can see the concrete infilled columns. You can see the main beams are covered for, say, fire. They are always been fire coated, and some of them are infilled. There is a steel beam with infill, and these are all deck things. It's an apartment. Sir, it is an apartment. It is a steel apartment, full steel, designed and delivered. So delicate. I call this as a Japanese, I mean, sculpture, sir. So the thing I'm just really expressing is we are no less than Japanese. We have created, time-lasting literatures, and I mean, the uh, Vedas and so many things for the world, but we are no less than the other people. But somehow we don't get and bring in the, to deliver such passionate things. So this is an example. I will call this as sculpture because it is really beautiful. All comforts, all safety, everything embedded. Still, it was a steel structure. Another one that really amazed me was a multi-story building, which of course is an earthquake reason. The blue part shown is a oil damper. That system, the blue thing, is all full of dampers, right, for the building. So they took the analogy of the tail of a squirrel. So they say this is the building, and when the squirrel tilt itself to the front, the counterbalance is given by the tail. It can put the tail in any angle it wants. Correct. So what happened now? See this oil stampers. So this is a completely a steel building, and so it is only an example. I just say it is not about whether we can sell. It is all about our imagination. Anyway, these two are my personal opinion. And summary of my first part of it is, of course, we are targeted around 160 kg. The biggest driver is rails, bridges, airports, and renewables. The PEBs are really good for the seventh pillar of Gat Shakti. And they're growing about 11% annual growth rate with compound, of course. And all steel flyovers, scalable, work-based solutions, it's for the people to decide. So also I would see airports are normal, but then the housing can be done in a very cooperative way. That is my hypothesis. So coal form steel housing is showed speed but lacked livability. New designs must focus on comfort, acoustics, and durability. So illustrative, we can always say 4 to 5 million tons extra the steel potential we have it. And the last message I say is that comfort, speed from sustainability, and just not the material substitution. Okay, right. So now, the high strength steel part, I'm going to only about 10 minutes to 15 minutes. So the high strength steel, when I studied, yield strength was always 250. right? When it came to 350, I said, what? 350? So when we did the project for the flyovers, we used 410 gig. Okay. But earlier, Sail had a Sailma 410, but this is from a different producer, but it is 410. So we could have some advantage on the cost, logistics, and these things. However, whenever there is a serviceably controlled design, right? High strength steel was not that. Like, for example, if you take a plate girder's deflection limit by span is span by 800. So, I mean, it's very difficult to get, because when you go for a high strength steel, your flanges are going to be smaller. And because the compression stresses or the tensile stresses will be lower, so for which your section becomes small. So, but there will be low moment of inertia. So you might get a strength, but it may not satisfy the serviceability. So span by 800 kind of deflections, probably high strength steel may not work. But still, I have seen people using high strength steel. I mean, deep um, high strength steel for the flanges and normal strength steel for the webs. That also I've seen that hybrid girders, but only problem is the interface welding. When you have a dual yield stress welding, so the fabrication has to be good. So coming to the advantages people see is height to strength weight ratio, of course. Columns are slimmer, um, and columns use Fy in their equation. So the higher yield strength really pays, provided your lateral strength you are able to manage with several other columns. So they say reduced tonnage. That's because logistic other costs and lower embodied carbon. See, the one point I'm just really very uncomfortable, but then sometime down the line we need to come and meet this. And better toughness and fatigue. In fact, high strength steels have a big advantage of fatigue. I'm also very impressed that if you take stainless steel, the fatigue rating is the fatigue behavior is very high. So when you compare with a normal steel, right, and then what is the extra money that you're putting, the fatigue performance is normally ignored by that. See, in fact, all these all steel bridges, in some of the load cases, the governing was the fatigue of the anchoring bolts, the fatigue of the anchoring bolts. So that was the whole issue. So we will get definite advantage if we go for high five. So there is a cost savings in fabrication, and this is now how the Eurocode. I mean, how the world over how are they doing now? Eurocode designs up to 700 megapascal, and they have to reuse, and they have the carbon metrics. And USA, they use up to 480, and they're researching up 690 seals. See, one of the things that we take a lot of our design provisions from Eurocodes, right? Many people criticize that these people take provisions from Eurocode, they copy, things like that. So, in the absence of relevant data for research, we can always take what and then we adopt it to yourself. We are more close to Europe because the Europeans have resource crunch. If you see European design, you will see a lot of tension in their design. They use lightweight cables. So because for the money you put on the material, the tension members are the most efficient one. So Europeans always go for a lot of stability checks, right, in order to conserve the material. But whereas if you say USA, they're abundance. In fact, the people say that the abundance of metals in US was one of the reasons that really helpful for the Allied forces. So America is just researching on 690, but in the Scandinavian conference, I have seen, I mean, people using up to 770, 690, 770, and things like that. And Japan is ultimate. This thing, Japan has TMCP steels, which are 1 gigapascal. yield strength, highly weldable, highly ductile. Right. So they are using it, things in China, they are up to 690 called the QAT. In India, we up to 550, which is come in 2062. But I'm not sure about a quick adoption of high strength steels, but still it is coming up. Now, globally, it is usually it's up to 780. You can see from this yield stress, as then the strength goes higher, you can see the ductility of the steel is reduced. So what happens if you take 780, but you are losing the ductility that we had it in your 250 steels. So one of the things is the codes of practice methods will get changed. Basically, because we are now a country in which we say minimum 20% elongation is needed, right? According to now, if you go for 550 and other things, the codes of practice give some allowance for the ductility. They say, okay, you can take up to 15, right? Or they are specifying a ratio of Fu, the ultimate to yield stress. So something is comes in the design so that your loss of ductility will be there. So one more thing is very important for us is that the weldability, because the steel is made, the welding also should have a matching microstructure. So there are people who make the new differential also do research in how the joining can be done in this. And of course, we are listed up to 550 in our seal, and we are what will happen is the higher strength steels, the ductility factors, plasticity, buckling, the serviceability check will get a complete overhaul or updating. So if you take what is IS 800, it is a lecture separately. In one of the lectures, I will give what is the new provisions of IS 800 vis-a-vis the 2007. And also, I would like to say why those changes are made. Many designers are a bit uncomfortable. As I told you, the Eurocode provisions are have a long take much of design office effort. There are several calculation checks you have to be make, but they're all pains of development. In my opinion, we are aspiring something good, and on the way we have to regraph ourselves to codes. In the absence of the technical data, that we need to adopt what people have done, and then the horse will, the cart will follow the horse. So what happens, you can see here the TMCP steels, right? The TMPCP steels they are Japanese made steels. So they can go up to 1 gigapascal with the carbon equivalent of, see, anything which is less than 0.45 is very good, nicely weldable carbon equivalent. So they got highly weldable steel. Okay. What will happen to IS 800? Okay, or what has happened to it? So we are likely to mirror or follow Eurocode second generation buckling code and curves. Because I'll tell you, because the Europeans have invested at 2007, we had the multiple column curves. If you go to US, they use Johnson's parabola, only one curve. But when we come to Europe, we have the Perry-Robinson type. 4 curves we have. We have A, B, C, D. And later they added A naught. There's one more curve which is above A. Say now what happened? In the onset of high strength steels, your residual stresses now present a completely different pattern. Sometimes it's very less. If you take our 250 steels, we use the usual Bethlehem steel, 0.35 at the edges, kind of residual stresses, which is completely different. So what happened? The whole thing that is embedded in a multiple column curves is the effect of residual stresses and initial imperfection, which actually has gone. Now we are going to adopt the second generation buckling curves, whatever research that become. Now bolts and welds are going to govern the design because your material you're going to make less, the forces are more, So whenever you join two material, there is less material, more force to be transferred. So the slip critical and fatigue is going to be IS 800 revision. We have not done anything on the fatigue side, but definitely with the literature reporting on high strength steel and the stainless steel, probably the fatigue provisions will improve for good. And secondly, the fire, this thing. See, when the code was written, it was just had a mandatory to write a code on chapter 16 on fire. But right now, after the Grenfell Tower collapse, which killed about 70 people, because it is not just a compliance anymore, right? It's not about 2 hour resistance or 2.5 hour resistance. Now we are going to have performance-based prescriptive, performance-based design systems are going to come in the fire design, not just prescriptive. Don't do this. If you have a thing, add this thickness, those kind of classes are on the off to go. And faculties from IIT Madras, Hyderabad, and Tirupati, they're trying to work out the code's provisions. They're taking a bit of time. They will come, I think. The hybrid system is the one which there is no competition between steel, concrete, timber, or I don't think this is all the materials are beneficial. So, but how do we blend them to make structures of different is what is the question. And of course, IS 800 will get revised as per Eurocode 2. And we will have separate sessions in which INSDAG will tell all the designers when the new IS 800 comes, what does it convey, why it was changed, all those things will be taken. So one of the things that I said, the high strength steel fabrication, they say if you have for the same, you're reducing sectional area if you go high strength steel. Between 490 to 700, your steel area is about from 2578 centimeters squared. So that means the amount of material you really handle or weld or put, it's less. Like, let's say weldments, they will be less, but the weldments themselves may be expensive. So this is the kind of perception people take in adopting high strength steel. Now, finally, before I close, I'll take a simple check on how the codes are going to be, because we are going to based on the Eurocode. The first Eurocode design philosophy was a prescriptive check and uses effective length method. Now we are going to have performance-based method. This is something like the direct analysis method, which the American code suggests. That means codes do not talk about analysis in my days. And I was a student. Don't codes say like you analyze linear elastic analysis, but the codes have started prescribing you have to use GMNIA. That means geometric material nonlinear analysis. Things like that have come into the code. So harmonized with that, they have now have this thing. Steel grades, routine up to 460. After that, there are several requirements for toughness and ductility rules. In fact, you will find in the tension member design, we are now taking a part of the weld also into our capacity. So that was very interesting because that was research was presented by some German professor. So that has been being adopted in the Eurocode. So it is the strength of the weld that you need to design is part of your design equation itself. So it's very interesting because in high strength steel, they are thinking part of the metal also contributes to that. So such things have come. So we had multiple column curves, so unified stability equations, and which is GMNIA consistent, geometric material nonlinear interactive analysis consistent. Now, this is a big difficult for many of the engineers in India or the Puritans or people like me. I don't, people, if I say, call me old, I said, how come you ask people to do a computer to do the design? Right? They have no idea of what's happening. So, but people say it's a hard reality, right? So computers have come, people live with that, and we should take the best out of it. And to give the fundamentals, it's a different thing. So, but the the way is turning towards that. Connections, we have the fatigue and slip resistance are redefined because they have to serve large forces. And fire design, it was a reduction factors for temperature and things. And now it's going to be a performance based. And composites or steel concrete composites is uh, closer with the EN 1994 or Eurocode 4. And now very close to that, not much of research has been done. Sustainability is little mentioned, and here reuse, embodied carbon, circular economy, and guidance. This is where I have a little bit of worry. Um, codes, I mean, uh, countries of developed countries, codes should not come and, put some restrictions. Of course, my country, India, is very alive to all these climate change and sustainability. Now, usability is actually, people say it was a fragmented, lot of cross-referencing, and now it is streamlined. So what I'm saying is, anyway, we are going to mirror Eurocodes for sure. I'm not denying the fact because we don't know much of this is available. So this is what I would say that we have um, for the high strength steels and things to come. Okay, so I will take a few questions. I finished, I have some 20 minutes. I left it for discussion. So, my dear friends, first of all, thank Mr. Ji, Manas. You have been so good to me, and I have worked with INSDAG for many years. So, in the, I mean, the fag end of my teaching career, that I always share whatever I have. The journal definitely we will do. And I have 10 of my students who are live wires. I mean, I'm not doing a PR, my dear. It is all my students are doing in best NITs and IITs. They do a tremendous job. So I want to empower them to take the mantle forward. So I have three of my faculties in NIT Trichy. All the three of them work on steel structures. And one in IIT Tirupati is on steel and fire. Of course, you're all do that. So invest. I have got many in Roorkee, in Hyderabad, in Bengal, a lot of youngsters are there. So this is the time that we need to invest our passion, money, and effort. All these young people. There are people from Bombay. They're doing what Guwahati IIT is doing. So several other people are there. So they should have a good union of this. And finally, everything grows in our country, and we become prosperous. And we can always say that we too have a little bit of contribution towards this. So thank you very much, sir.
Thank you,
Thank
sir.
you, sir.
I'll let us speak to you and take the references of all your students, and I'll try
Okay,
to
sir.
form a union, sir.
Okay, sir. Okay.
Thank you.
Sir, before
So
we go
I'm
to the
visible now,
question
sir.
and answer, sir, 1 minute before we go to the question and answer session, I just want to read what Mr. Dr. Prem Krishna has written in the chat box. I have known Professor Jayachandran as one of the best designers and researchers in structural steel in India. I am very happy to listen to this brilliant exposition of the overall Indian scenario, the role of INSDAG, and going down to some very illustrative examples of application. May I take leave and compliments to Professor Arul. So this was the note delivered by Dr. Prem Krishna. So now the house is open. Sir, we had actually two types of your presentation. One was the futuristic, where consumption can go on increasing, and the other on high strength steel. So I would ask the participants to unmute yourself and ask questions if you have anything.
Sir, I'm in the frame. Am I visible?
Yes, sir.
You are very much in the frame, sir.
Okay.
Yes, Utkarsh Gupta, please unmute
Utkarsh, what
yourself
are
and
you
ask the
doing there?
question.
He's my student.
Good evening, sir.
Good evening, Utkarsh.
Yes, sir. Very excellent presentation, sir. Sir,
Oh, thank you.
yeah, I have two questions, sir.
Yeah,
Uh,
please.
so my first question is regarding the concern of ductility in the concept in the context of high strength steel grades. So most of our steel structures are governed by buckling or stability criteria. Why is that the force in the thing is of a big concern in the design?
No, you mean to say, can I come? I mean, you mean to say why the loss of ductility is not considered in the design?
It is a concern when
Yeah,
going
it's
to
a
the
concern. Yeah, that's all I'm saying. Say it. If you take traditional 250 steels, we have I mean, a large amount, even more than 25% of elongation. So when I aggregate the forces in the earthquake design, what is the philosophy that we are saying is we are actually aggregating the forces and we push them through few beam column joints and beams, make them yield, and then we'll make them absorb the energy. Am I right? Right.
yeah
So basically is we are aggregating. So now what happens is that your principles will be the same, your performance will be the same, but the framing system, right, which will deliver the amount of energy dissipated, definitely in a say. For example, if you take coal form steel structures, okay, a lot of cross frames are there, right? So in an earthquake, what does absorb energy? It's a distributed energy absorption that happens here, because in hot rolled we have collectors. The forces are collected, pushed into the beams, to the connections, to the columns, correct? So what we have to do is, so probably we'll go for a different framing system which will still give us the same amount of energy dissipation, of course, with the performance.
but how
Did I
about
answer your
the
question?
gravity systems? So
Yes,
in the
please go ahead.
gravity systems, that requirement is not such stringent. So
Yeah,
how about,
see, gravity, I'm jolly well I use, right? In gravity systems, I have a dual system. In gravities, I have a higher strength and I have I mean very sleek columns. So they have a less lateral restraint. Add one more bay. Simple. You
yeah
got the point. So
yes
we get it by the geometry. If the if
yeah
the if the strength doesn't come by the material, why don't they take it by geometry? So that is how I look at it. So still, high strength still can be used in earthquake applications, but the way you flow the forces or absorb them will be different.
right great. I have one more question just so as an eminent structural engineer and based on your previous experience on the design of anchor frame systems for uh, the highways infra. What are your thoughts on use their application on multi-grade? Uh, let's say there are multi-grade projects coming up in future. What are your thoughts on that?
Absolutely good. Absolutely good. I'm telling you. Because see, the way that we are transferring the force on the end, right? Right?
Yeah,
So, I mean, traditional, I mean, how big can you go for a pile foundation and, I mean, pile cap? How will you transfer the loads, right? Again, through we say tie actions or deep always that is the only thing that is available, right?
right.
But in our system, we take straight into the foundation. So in all that anchor frame systems, the pile cap as an integrator of the force flow on that,
Post
right?
transfer.
So yeah, force transfer, not by the usual tie strut and tie method, right? That's not the only mechanism by which we can transfer. Of course, in multi-tier systems, definitely we can try. See, Utkarsh, economy is one thing, ingenuity another thing. But I'm not saying this, don't flout economy. It has to be economy. But then we should not be thinking very traditionally, but it's a good concept. I have seen it is a Japanese concept, worked excellently in earthquake, right? And time tested, and we were able to learn from them. Very simple.
And some limitations to be careful of.
I do agree. Of course, yes, it is definitely a limitation. If the rod starts bending, what be the B by T, the diameter to the length of the anchor rods? Those are the things will come. Correct.
Yeah.
So, but the conceptual, Utkarsh, the overall concepts try to adopt for a two-tier system.
Yeah, thank you very much, sir. Very good to see.
Sir, we find Dr. N. Subramaniam in the participants list. So I would request Dr. Subramaniam if he has any question. Sir, Dr. Subramaniam, please.
Yeah.
Yes, sir. Yes, sir. Nice seeing you.
Good morning, sir.
Good morning.
From Gothenburg. Gothenburg.
Gettysburg.
Gothenburg, I'm sorry.
Of course, I know Dr. Jayachandran for several years. I forgot how many years because I probably 30, 40 years maybe. He is also from my college, Tyagarajar College of Engineering. Of course, he did PhD from IIT. I also did PhD from IIT. So we know each
Sir,
other.
my first guide was Ganapati Chettiar.
Oh, I see. My guide was also Ganapati Chettiar. I was the first PhD student of Professor Ganapati. Of course, today he has given a wide spectrum of steel design, from ordinary steel to high strength steel. I don't have any question as such right now. Probably, if I have any questions, I will discuss with him.
Sir,
Okay, sir.
you are the one which has been networking with the professional community with selfless motive, sir. And your
Thank you.
association with the INSDAG, really good. You are a firebrand.
Thank
You
you.
have 20,000 followers on LinkedIn, sir.
1 lakh.
1 lakh, I'm sorry. Maybe. Sorry, sir. Yeah, Manas, good. The next question.
Okay, sir. Sir, I think there is no more question. Only the chat box is filled. That's the thank you, sir. Thank you, sir. The program was quite good. So that was in the chat box.
Actually,
So as there are no more
question.
questions,
There was a question on what welding practice do you recommend for interface welding in hybrid plate girders?
Yeah.
okay, sir.
Sir, in hybrid plate girders, we will always say matching welding, right? So currently the thing says is use the higher of these two for your welding. For example, if you are using 250 and a 350, so if you use E60 electrodes for 250 is fine. But if you are using 250 and 350, go for E70 electrode. So that is the kind of core practice. Try to have unified values. So there is no there is no explicit thing is. So instead of E60, the matching welding should be E70 because the flanges is E350 and the web is 250, which will be accurate.
Good evening, sir.
Okay, sir.
My name is Deepak. I'm talking from Steel Authority of India Limited.
Yes,
Hi,
please.
sir. I just wanted to know how whatever you have projected, these are the areas where the steel consumption can grow.
So my view.
Right, obviously, sir. But what are the steels which we are not making in the country now, and what are the steels which you would require according to your projection, so that we, being a steel producer, can focus on bringing in that type of steels into the country if we can?
Sir, plates, of course. It's a major sale, of course, sir. Plated construction. Now people have learnt it. So plates of different sizes, higher thickness are good. Because I feel up to 50, there is no problem. If you go 50 plus above, you need preheating. So earlier, we used to discourage people using 50 mm. Beyond that, because we say it is very difficult to do preheating. Now, today, the technology has increased. So one thing that we can say is higher thickness plates are fine. Okay. And rolled sections, I don't know how much you produce and sell. But there was a thinking once, when you have a deeper sections available, let's say, I think somewhere 900 some private players are making. So they say you can absorb it in the fabrication cost. So these deep girders are only for housing. When there is a commercial building on the thing, that'll be very helpful. For bridges, normally it overshoots more than 1.5 meters, so only 3-plated systems. So there was a time where the distribution of the roll beams sizes were not enough. So it is, I mean, actually, I don't know how relevant it is today. So I can tell stainless steel is coming. See, suddenly it pumps up. For example, the United States, they have just had a new code. When I went to the conference, the Nordic Steel, there was a lot of papers on stainless steel. And we are now with NIT Surathkal, Dr. Vijay is putting through a stainless steel code. And it is coming in the one bridge in Kanyakumari, which is connecting the Valluvar statue and the Shiv, the Vivekananda rock. It is of stainless steel. Okay, so another 3 projects are coming in Chennai on stainless steel. Right. So probably government also, maybe some mention is there on stainless steel. So I feel more this thing come to stainless steel. Of course, Salem is not there anymore, I believe. But that's my point, sir.
Salem is still making stainless steel, sir, but I don't think so for structural purposes. But I got your point. Right, sir. Thank you, sir. Thanks a lot.
Hello. So any other questions from the participants?
Good evening, sir.
Yes,
Good evening.
How are you, sir? So this is Kishore Kumar.
Oh,
sir,
Kishore,
actually,
Dr. Kishore.
Yes,
Dr.
sir.
Kishore, yes.
Sir, actually, for
He's
your
my...
example, you said that, sir, for 1 km of bridge, we have to spend 110 crores, and with 1,000 tons of steel. So I think around price material cost is coming around just 10 crores. So how we can reduce the overall size of the project by using any other construction techniques? Because the material cost is around less than 10%. Like from the statistics, what you said, 1,000 tons and 1 ton.
Understand. See, the way, take it as indicative. See, it is not thorough usually by a meter square kind of calculation. So the steel made it. So usually there is a substructure cost, there is a foundation cost, the piling cost, because all will get added up there. So a very good design is one in which the substructure cost is close to the superstructure cost. If such a design is made, it seems to be a very good bridge design. So to answer your question, sir, we need to try new techniques. For example, there is one more bridge system coming. We're all thinking, what can we change? May make it a circular, or can we have things like that? So how's the force flow? And I don't have a ready-made answer, but we are blessed with all that technical knowledge to innovate. That's what I can have.
Thanks. Yes.
Okay. So Kishore is my grandchild. He's a student of my student, the PhD student of my PhD student.
Thank you.
So 2 generations.
Yes, sir. Sir, still Kishore will be a very live wire in transmission line towers, design, all those things. He will spend his whole life, sir.
Thank you, sir.
Sir, if you can go to the chat box, there is one question. Sir, while using high-strength steel, we have to depend on high-quality vendors for manufacturing. In recent experience, we have HSFG boards for 12.9 grade, which fails even without load. Kindly share your views on it.
Sir, unacceptable. Unacceptable. Right, unacceptable. The material quality, like, sir, 12.9 is supposed to go in with high-strength steel, right? We even say 8.8 is very common, 10.9 is 12.9 has to be there. Sir, we have seen some failures also reported from Bombay. This is not acceptable. Sir, the quality control, when we receive on the site, I make everyone, what is the record of your quality? See, there was one company which made huge loss because when something is delivered to the site, they don't have a record whether it meets the quality or standard which they specify. Right. So when something is dumped and you are paid, probably we should not be taking materials and these things which are of low standard or which don't um, live up to the specifications. Very sad, sir. If such things had fallen, please don't get disheartened. Then you go for good vendors. They have a third-party check, and always keep quality control in the prime of yours.
Let us go to the next question. What is the future of corrugated web
Mr.
beam?
Ghosh, this should be the last question for Professor Arun Jaiswal. Already he has spoken for more than 2 hours. Okay. This should be the last question.
Okay, sir.
Sir, they can always send a mail. I'll
Yes.
always say, yeah. Sir, the last question was?
Corrugated web beam. What is the
sir,
future in India?
corrugated, sir, I mean, see what happens when lateral torsional buckling happens. About the minor axis, the moment of inertia is always very low because the web. See, in order to increase in the minor direction, if you have a corrugation, it will increase your minus. But what happens? A simple question: how will you weld a corrugated web with a flange? Because it is going to be winding. So I have to do a manual welding, which is not normally done. Right. Now, if you have a welding torch equipment to do the curved welding, well and good. But normally I've seen only linear torches. So all the submerged or welding have torches which will do a linear welding. So in my opinion, either the trapezoidal or a sinusoidal web, the welding is an issue. If someone can overcome that, then it's even robotic. Sir, if you have a robotic welding for a sinusoidal, no problem. Go ahead. But the commensurate increase in the lateral torsional capacity by going for robotic weld is not there for certain span. Sir, what we say is we optimize for certain design space. So all I'm saying is that cost, that fabrication, which will fit in some design space. So using that design space is absolutely no problem in using the corrugated girders because we have done it for a purpose. Correct? So that's what my opinion will be. Please go ahead. But in our designs, we have not seen the commensurate increase in this. Of course, many people have come and certified. It is good. But I'm not really able to say off the cuff in what design space it will be advantageous. Definitely it is advantageous, but I don't have the answer to say.
Okay, thank you, sir. And I would also thank you, Dr. H. Subramanian, because
sir, he said avoid web
when you were
stiffness.
verbally giving the answer, he was replying to the chat box.
No,
so
that's fine. No, I want to
your
tell
job
him.
has been done by him.
No, I want to tell him. He said avoid, sir. He said avoids the web stiffness. In fact, in the Europe, they don't do web stiffener at all. In fact, for them is no intermediate stiffener, straight unstiffened blaze only. So that makes no big because you're no big cost.
Hello, sir. Good evening, sir.
Mr. Ghosh, please.
Yes, I think this can be the last one because let him ask the question.
Yeah, no problem.
We should not go on extending. Sir, please furnish your question.
Sir, good evening, sir. Myself, Kasi Sunathan. Sir is one of my examiner while I am doing PhD in IIT Roorkee. I am Akhil Upadhyay.
Oh, okay. I remember. Yes.
Yes,
You did with the
FRP box.
Right. Okay, please go ahead.
Yes. So my question is, I'm seeing so many research work regarding castellated beam. I mean, high strength cold form steel. I mean, high strength steel castellated beam. I didn't so I seen many works, sir. But in IS code books, I didn't see anywhere regarding this castellated beam.
Yeah.
I want to know why it is not added in the IS 800. First question. Second thing is, Casted beam, if you go with cold form steel, it is advisable, sir, because so many welding work we have to do. So this question I want to know this answer from your
Sir,
yes.
sir, first question, to answer the first question, codes do not specify what section, what size to do. Codes will say what is the shear capacity. When you have a B by T, check whether it is less than 60 by 7, right? So you can do a castellated beam design, right? Absolutely no, with the provisions that are available in IS 800. Absolutely. The code does not disallow, but it will always say what is your moment capacity, whether the shear can be transferred near the webs. Correct. Those are the things. So castellated beam, it is for high moment, low shear problem. When the shear is low, right, then easy
Yes.
to transfer shear in your castellated webs.
Yes.
Correct. So it is not for high moment, high shear. It's very difficult to make, and of course the fabrication cost. So that's my point. If your moment is going to be, shear is going to be very low, castellated may become these things, but there is always a cost of cutting and welding will be there. Second, castellated beams in cold form steel do not fit in. It will
Yes.
be disastrous,
Yes.
right? So not a good idea to try.
Yes, sir. Yes, sir. So
Okay.
somebody I see some of the papers they are starting to work.
Sir,
Casted
papers you
beam.
can always, finally you have to
Yes.
come and build, right?
Yes, sir. Yes. True, sir. Thank you. Thank you so much.
Right, sir.
Thank you, sir. And
Sir.
let us now come to an end. I would thank also Dr. N. Subramaniam because he is continuously replying to the chat box, doing the job what Dr. Arul should have done. So thank you, sir.
He's a
Sir,
great soul, sir.
INSDAG has also a knowledge portal which we are uploading with various technical papers and journals. So I would request the participants to go to it, and I uh, presume that they will get something for their food. So with this, I would thank each and every participants, Dr. Arul Jayachandran, especially for giving us so much of time, and we were connected with him from day one. So we chose him as the probable speaker, and we are fascinated by his presentation. With this, I would thank everybody, and I would request participants to go through our websites and to interact with us whenever required. Thank you very much. Thank you all. Good night.
Thank you.
Thank you,
Bye.
sir.
Thank you.
Thank you.
Sir, thank
Thank
you,
you,
sir.
Suryanarayan
Thank you,
sir.
NS, sir.
Thank you,
Mishra
Raghu
ji.
sir. Thank you. Thank you.